rather than static because of the fluctuations in the various components of the soil environment. Because of the fluctuations in the various components of the soil environment. Physically, these components can be subdivided into solid, liquid, and gaseous. These components can be subdivided into solid, liquid, and gaseous. Subheading: the solid component of the soil. These are either minerals or organic. The solid component of the soil are either minerals or organic. The mineral materials comprises of particles of varying sizes. The mineral materials comprise of particles of varying sizes, and these help to describe the texture of the soil. Particles up to 50 micrometer. Particles up to 50 micrometer in diameter are usually fragments of the parent rock. Those are between 2 to 50 micrometer. Micrometer is the word. Those of between 2 to 50 micrometer in diameter are silt. To 50 micrometer are silt, which comprises of primary minerals. The smallest particles, which are below 2 micrometer, are clay. The smallest particles, which are below 2 micrometer, are clay particles, which also comprises of secondary minerals such as kaolinite. And elite. The clay particles form an important portion of the solid component of the soil. The clay particles form an important portion of the solid component of the soil. For example, they have large specific surfaces. They are colloidal. They are colloidal and electrically charged. They are colloidal and electrically charged. They are colloidal and electrically charged. They are negatively charged. And this, therefore, makes ion exchange in the soil possible. This makes ion exchange in the soil possible, e.g., clay minus clay ion plus potassium ion give you potassium clay. Such a negative adsorbed ion can then exchange for another ion of like charge from the surrounding medium. Such a negative adsorbed ion can then exchange for another ion of like charge from the environment. The organic portion of the soil is supplied from both plants and animals. The organic portion of the soil is supplied from both plants and animals in addition to artificially added components such as fertilizers, insecticides, and industrial wastes, etc. See, that guy, two of you are get out. Get out, my friend. That guy is standing and the other guy talking. You are outside. Please, let's behave ourselves. When it's time to laugh, we laugh, and when it's time for business, please, let's do our business. So I said the organic portion of the soil is supplied from both plants and animals, in addition to artificially added components such as fertilizers, insecticides, and industrial waste, etc. A large portion of organic materials can be decomposed by soil microbes. A large portion of organic materials can be decomposed by soil microbes, and the portion which is not so decomposed becomes, and the portion which is not so decomposed becomes the amorphous humic material. Becomes the amorphous humic material. Where is the class rep? Where is the class rep? Collect the assignment I gave everybody now. And please close that door. Nobody comes in again. Close that door, Mr. Man. Hey, sit down. Just, if you come to me to collect it. Close it at the back. Yes, lock it now. Yeah? Go ahead, let me see. Turn it down. Count everybody for me. No, count everybody, my friend. Please, let's continue. Let's continue, please. You can collect it without making noise. Let's continue, please. So I said the amorphous humic material, which is referred to as the humus, which is, when it comes to it, just give in. You don't need to make a noise, please. Which is referred to as the humus. Humus is a complex mixture of many substances. Humus is a complex mixture of many substances. They like, just let me see you interacting with those outside. Tell them to leave that place. Please leave the side this way. Leave that place, please. Bring the assignment now. You have 1 minute to submit, please. Go and help him to collect the remaining ones. Go and help him to collect. Go and ask him to collect. Class rep, bring it. If you still want to submit, raise up your hand. You have not submitted yet. So everybody has submitted. Raise up your paper, the assignment. That's what I mean. Pass it to them. So let's continue, please. So I said humus is a complex mixture of many substances and comprises of small water-soluble fraction and consists of a small water-soluble fraction and a large insoluble dark-colored portion. And a large insoluble dark-colored portion. The insoluble portion consists of humic acid, fulvic acid, and humic. Humic acid is extractable with alkaline. Humic acid is extractable with alkaline, but insoluble in acid. It is very resistant to microbial decomposition. It is very resistant to microbial decomposition. Fulvic acid is also extractable with alkaline, but soluble in acid. It contains carbohydrates and protein materials. It contains carbohydrates and protein materials in addition to other constituents. Cumene is extractable in alkaline and heterogeneous in decomposition. Now let's go on to the liquid component of the soil. Soil water is constantly subjected to change. Soil water is constantly subjected to change because of many reasons. Such changes affect the soil microbial population. There are 4 types of soil water. Number 1 is gravitational water. These drain out of soil. Gravitational water drain out of soil under the influence of gravity. Gravitational water drain out of soil under the influence of gravity. If I had to submit, let me see your hand up. What happened to submitted? So when we say that it drains under the influence of gravity, what does that mean? So say it when I can allow you to submit.
It's drained. When there is a force of gravity applied to it, then it drains.
You drain it.
Like when the force of gravity is applied.
No, speak to the teller. Let them hear what you are saying. Man. If you get it, I will allow you to submit your assignment. But if you don't get it, we'll continue our lecture. Speak to the mic. Let everybody hear what you are saying.
So what I'm saying is when the water drains. Okay, when the force of gravity is applied on it, then it kind of drains.
Who else? I've not submitted. I want to answer the question. Where is that my friend that started yesterday? Where is that boy that started yesterday? He didn't come today. 2 of them. Let's go on. Where is he now? Bring your chair here now. This way is still here for you. Still here. Bring your chair to this place. You're going to be the head of a home. Are you going to be sitting at the back in the home too? It's in the front, but you're the number 1 in the home. So in the class now you're sitting at the back. But later in life you want to be in the front. Later now, with the women they are doing younger for you. And they are doing boss for you at home. Because in the class you are sitting at the back. And I hope you are going to get the highest in this course. Come and sit down here. Follow this place. Follow. They will give you seats. You should get the highest in this course. That's why I will know you are a real breadwinner. And since some people are making change now, you should go and open a bakery there. Yes, now. The man is the breadwinner. Women are making change. You to go and start bakery. So that you show that you are a real breadwinner. But actually, anybody can own a bakery now. So anybody can win the bread. The man can own the bakery, a woman can also own the bakery. Gravitational water, gravity. Mr. Man, what do you mean by gravitational water? Where is it going? Where is the water coming from? Where is it going? Quickly. It's coming from up and going down. I will take that again. No, don't write anything. Those which drain out of soil under the influence of gravity It is available to soil organisms and holes in, you didn't write that. It is available to soil organisms and holes in transportation of materials. And helps, it is available to soil organisms and helps in transportation of materials. So, I wanted one person to answer it among those who have not submitted, and she missed it. You're just saying by gravity. What is gravity? It's going to pull it down. When you enter the water, it goes down. It doesn't go this way or that way or come up. It goes down. That's gravitational water. Number 2, capillary water, which is contained in the soil pore spaces. Capillary water, which is contained in the soil pore spaces. Pore, P-O-R-E. Its role is similar to that of gravitational water. Its role is similar to that of gravitational water. So this capillary water is in what? It's in the pore spaces of the soil. The pore spaces of the soil. So the pore spaces of the soil, the pore space of the soil, if it does not contain water, what will it contain? What's that? From outside. Okay, number 3, osmotic water is held around particles of clay and humus. Is held around particles of clay and humus. It is less available to soil organisms. Number 4 is hygroscopic water. Hygroscopic water. Hygroscopic water forms a thin film around soil particles. Forms a thin film around soil particles to which the water is strongly adsorbed. Adsorbed. Full stop. It is the least available to the soil organisms. It is the least available to the soil organisms. It is the least, L-E-A-S-T, available to the soil organisms. Full stop. The state of a soil water may depend on the amount of water present in the soil. The state of a soil water may depend on the amount of water present in the soil. E.g., a soil which is saturated with water can drain its excess water. A soil which is saturated with water can drain its excess water. So how can it drain the excess water? A soil is saturated with water and can drain the excess water. How can it drain the excess water? Can drain the excess water by gravity. The amount of water which remains after removing all gravitational water is referred to as the moisture holding capacity of the soil. The amount of water which remains after removing all gravitational water is referred to as the moisture holding capacity of the soil. As the soil becomes dried, full stop, as the soil becomes dried, the pore spaces become filled with air. until all capillary water is removed. Until all capillary water is removed, leaving only the osmotic and the hygroscopic water. Leaving only the osmotic and the hygroscopic water. So we have looked at the solid component of the soil. We have looked at the liquid. Now let's look at the gaseous components of the soil. Gaseous components of the soil. So we have gravitational, capillary, osmotic, and then gaseous components of the soil. The pore spaces of the soil are filled with liquid and gases. The pore spaces of the soil are filled with liquid and gases. Normally, air moves into any soil that are free of water. Normally, air moves into any soil that are free of water. Remember, nature abhors what? Nature abhors what? Nature abhors. Who wants to give us the answer? Nature abhors. Yeah? Who wants to answer the question now? Nature abhors. Eh? Well. Wait, so he's. I think your generation is called Gen Z. I don't understand though. Gen Z, I don't know many things. What's happening now? The Gen Z wants to know many things. They don't know many things. Nature abhors something. Okay, write it down. Go and find it. Nature abhors dash is a general statement. Microbism. How can nature abhor microbism? Nature loves microbism. Abhors. Normally, air moves into any soil that are free of water. And from that, if you know what I'm saying, from that one, you should know that nature abhors something. How can you abhor? If there's no water there, air will be there. So the pore spaces cannot just stay like that. So if there's no water in the pore space of the soil, air will be there. So something must be there. That's why I say nature abhors something. How can nature abhor air? Yeah? It starts with, the answer starts with V. The answer starts with V. Nature abhors something that starts with V. Okay, somebody should Google it. Let's get the answer now. Somebody should Google nature abhors. Just search. It will bring you something out. Google the something now. Google it. Yes. Nature abhors what? What? Yeah? Take them. Take now. Say it's what the person said. Give it to the person. Let the person talk. Speak into the mic.
Nature abhors a vacuum.
Abhors a vacuum or vacuum. Say it properly. Say it, speak loud. Let the backbenchers.
Nature abhors vacuum.
So you hear now. Don't forget to. So nature abhors vacuum. in 1998 when you are born 1998. No. You are not. You're not born 1998. So when were you born? 2000 or when? Okay, 2005, 2006, 2007. Okay. In 1998 when General Sani Abacha died in Nigeria, everybody was happy. Do you know after how many hours they put another person, they appointed another president? Within 1 hour, the seat, nature abhors vacuum. The seat, that seat, somebody must be there. Because nobody is there. And if nobody is there, it will not be funny. Somebody must be on the seat. So nature abhors vacuum. So when a leader go or this and anything, somebody else will take the place. So in the pore spaces of the soil, if there's no water there, air will be there. So when water comes, it will push the air out. If there's no air in the soil, we say that the soil is what? Water locked. That's what I was saying, waterlogged soil, they will now go by gravitation, by gravity. The water has to now go down to the water table. So if there's no water in the pore spaces, there's filled with air. And then we also do not have capillary water. Then what we have is osmotic water and hygroscopic water. And those ones are not in the pore spaces. Like now that we're having dry season, rainy season going, the gravitational water will be less or non-existent. You get it now? So there's no rain. So which gravitational water do you want? So the water you are going to have is just the one not in the pore spaces. The pore spaces are filled with air. So what I'm going to be having is osmotic water and hygroscopic water. So that means the water that they absorb. And it will be when the environment is very dry, the osmotic water will be very reduced, that it cannot sustain the plant, especially if it's annual crop or biennial. But if it's perennial, their roots have gone down so they can still get water. So let's go on. So where did I stop? Free of water. While water in turn displaces air. While water in turn displaces air. Such a condition becomes more pronounced in poor drainage or waterlogging. Such a condition becomes more pronounced in poor drainage or waterlogging. Stop. The gas that is found in the soil constitute the soil atmosphere. The gas that is found in the soil constitute the soil atmosphere. However, this is not identical with the composition found above the earth. Generally, the CO2 composition in soil air, exceeds that of the atmospheric level. Exceeds that of the atmospheric level up to 10 to 100 folds. Up to 10 to 100 folds. While oxygen is more or less. These differences arises from the respiratory activities of microbes. These differences arises from the respiratory activities of microbes, the plant roots and animals. These differences arises from the respiratory activities of microbes, the plant roots, and animals. Soil microbes differ considerably in their responses to the changes. Soil microbes differ considerably in their responses to the changes in the CO2 ratio of the soil atmosphere, in the oxygen-carbon dioxide ratio of the soil atmosphere. The concentration of CO2 in the soil may affect the pH of the habitat. The concentration of CO2 in the soil may affect the pH of the habitat, may provide a source of carbon for atmospheric microbes, or have a differential inhibitory effect on the heterotrophic microflora. Let's talk about soil temperature. Soil temperature can influence soil microbial population. Soil temperature can influence soil microbial population. The amount of solar energy which can be absorbed. The amount of solar energy which can be absorbed by the soil depends. The amount of solar energy which can be absorbed by the soil depends on several factors, which include the color. Several factors which include the color, direction or slope of the soil, and the amount of vegetation cover. Direction of slope of the soil and the amount of vegetation cover. They're outside. We open the door for them. So if it's an interview you are supposed to go for, you have to be there by a social time. That's why you come late. There are still serious jobs people are getting in this country and worldwide that they don't need connection to get it. Sure you get. There are jobs that they don't use connection. That kind of job now, they now give you time to come for interview. You didn't go for the interview. So you are just coming, Abi. So I'll take that again because of you and I'll ask you a question. I said soil temperature can influence soil microbial population. Because if the temperature is too hot, the microbes, if they cannot tolerate that temperature, they will leave the place. They will die off or peak race. So only the ones that like high temperature will be in that kind of soil. So we now say the amount of solar energy which can be absorbed by the soil depends on several factors. One of the factors is color. Black soil, different from another kind of soil. Brown soil. Direction of the slope of the soil. If the sun is coming like this, the slope too is facing like this. easily, the soil will be hitting on the soil. But if the soil is sloped like this, the sun is also going like this. So some portion of the soil will be covered because the slope is in this direction. And I said also the amount of vegetation cover. So, Mr. Man, how does vegetation cover affect the temperature of the soil or affect the amount of sunlight that hit the soil? What? By what? By what? Which branches of the company? Branches of the company. Branches of what? Of the branches of the plant. So let's say it's a grass. All these grasses now. So the grasses have branches. What? Yes, vegetation. So the grasses are not vegetation. About trees. Are trees part of vegetation? Trees. They are not vegetation.
They are not part of vegetation.
Ngo. Trees are not vegetation.
They have.
What do you mean by vegetation? Yes. You. What is vegetation? Stand up. What is vegetation? All right, you check that out. Vegetation cover, talk about green plants. So you are correct, but you are not. I was telling the 300 level students when I asked them a question, when I was seeing them this morning, about bacterial growth. Then we went on to talk about doubling time. So I said, what is doubling time? What is doubling time? Yeah, go on. The amount of time to okay. Doubling time is also called what? Can you tell me more about doubling time? Apart from that, it's the time to reproduce, to double. It's also called generation time. Tell me more. So I was telling them in that class that now we talk about doubling time. What is doubling time? Say time you take the cell, the bacterial cell, to double. Now you say it's the same thing as generation time. That's 2 points. But I want to give 3 marks. And each point is 1 mark. So you now say it's the time it takes to double. The time it takes to double, I will give you 0. Because it's bacteria we're talking about. What about somebody say the time it takes a microorganism, I will still give you. Because bacteria is part of the microorganism. If you say the time it takes fungi, it's not mycology now. The time it takes protozoa to double, inside bacteriology. So you can see now, you are saying the answer, but you are not using the terminology. So the time it takes a bacterial cell to double, and that's 1 point, 1 mark. And it's also called generation time. Another 1 mark, that means you know something. Then, for example, if a bacterial cell is 20 and it doubles in 20 minutes, that means the doubling time is 20 minutes. That shows me that you know something. Another 1 mark. So if we now just say, you sit down there and say, doubling time, the time it takes bacteria to double. Out of 3, now 1 mark, because it's only 1 point you gave. So the same thing we're talking about here. You say vegetation cover. And I said you explain. You said that it depends on the factors which include color, direction of the slope, and the amount of vegetation cover. Now you're talking about trees. What about grasses? So if we talk about trees, that means you have idea. You get one point. Then somebody goes on and said, talk about grasses and some other things, the person is like, he knows more. But if you now say the vegetation cover, they do not allow the sunlight to hit the soil directly. Fine. One point. But now you didn't talk about trees, you didn't talk about grasses. The effect of trees will be more than grasses. Because you now have a forest growing in a tree, trees growing in a forest. So you have them forming their canopy. So the amount of sunlight that will get to the soil will be less. So if you now just say in that direction only 1 point, maybe it's even this one are like 5 points, 5 marks, and every one with 1 point. So let's go on. Generally, a dark soil absorbs more heat than a lighter soil. Generally, a dark soil absorbs more heat than a lighter soil. We did, some of our lecturers, like Professor K.I.T. Eniola, who is a VC of Kogi State University, Kaba. He did some experiments many years ago when he was still lecturing here. And they used the color of container because he was working on water microbiology. So he got different container. This one now is like white container. He got black, he got green, he got other ones. So their work shows that, so they put water inside, the same amount, the same water from the same source. After some time, they were checking the bacterial load. They put it in the sunlight, checking the bacterial load. They discovered that the one that has dark color, most of the bacterial load is less. And it's supported by what you are reading now. So generally, the dark soil absorbs more heat than a lighter soil. So the dark container, you absorb more heat. In that case, it will be able to, the water will get more UV light, which will kill more bacteria. So by the time you now check the bacterial load, it will be reduced. That's why you see many places in our country we have what color of a tank? What's the color of the tank? Black. But when I traveled to India, I was seeing white tank. I was now saying, what is all this one now? This thing, need to have done research on this thing that my student did now. What is happening here? So that made me now to go and check again. So I checked, I said, this thing we did is dark, that is, why are they using white? This thing, everywhere white. So in that place, the sunlight, when there's time for 4 months of sunlight is very, very intense. Very intense. There was we're enjoying this place now. We're enjoying it, seriously. Intense sunlight from so months for 4 months, yeah. The sunlight is intense. That if you, like this, you can take your bath 3 times and there's water, but the water to be hot. Now you want to get the water, like the tank is outside now. So what they did is our own tank, we just put it outside, open to sunlight from here, sunlight from here, sunlight from here, sunlight from here, sunlight from up itself. This one, they'll put the construction of the building in such a way that they will want to hide the tank so that sunlight from the side will not hit it. You put on this fan like this, now heat, they blow. Singlet, when you want to remove it like this, you see the water, you have to be careful before you remove it. Because the water, your singlet is holding water already. So based on that, they cannot use white and black tank again. If they use black tank, that means that hot water will just drop. This one that you bath with the water, so we look what is the water is not cold, it's hot. So based on that experiment that was done, when I got there, I saw white. I was wondering, what is all this white about? What is this white about? until later on I got to know. The types of microorganisms found in the soil will depend on its response to temperature. It depends on its response to temperature and the temperature of the soil itself. And the temperature of the soil itself. And these are cycrophiles. These are cycrophiles. Cycrophiles. In brackets. Minus 5 degrees C to 20 degrees C. Cycrophile. Minus 5 degrees C to 20 degrees C. Mesophiles. 15 degrees C to 45 degrees C. Thermophiles. 45 degrees C to 65 degrees C. Hyperthermophiles. 80 degrees C to 113 degrees C. Let's look at the microbial ecology of the soil. Microbial ecology of the soil. The soil contains the following major groups of microbes, mainly. Let's see, I've taken this, we've taken this already. The soil contains the following major groups of microorganisms, namely actinomycetes, algae, bacteria, fungi, protozoa, and viruses. If I don't have time, I want to complete this today. Actinomycetes, algae, bacteria, fungi, protozoa, and viruses. The relative proportion of these groups depend to a large extent. The relative proportion of these groups depend to a large extent on the condition of the environment. The relative proportion of these groups depend to a large extent on the condition of the environment. Let's say I give you a question. Question 1A. The soil contains actinomycetes, algae, bacteria, fungi, protozoa, and viruses. The relative proportion of these groups depend to a large extent on the conditions of the environment. Discuss. Discuss. If I say discuss now, half a page, you don't finish discussion. If it's your friends, you are discussing chin now. You can discuss from now till next year. Because you are not confident that, don't let me discuss in this note, in this question. The same way you are discussing with your friend, discuss in the exam question. Everything that you know about what the question is, you write it there. That's the same thing you write everything you know about chin. Like chin now, do you use butter for this chin? See, plenty butter. If you use plenty butter, it will break better, and it will not be doing kolo. Is that not? So that is discussion. So someone that does not know anything about chin is also discussed because they have eaten some kind of chin. Say, this chin is. There are some chin in ShopRite. See them, they are bigger than this. Now, why is the own small? That's still part of discussion. So the more you know about the subject, the more everything you know, you say. Now they say discuss. Then you just write half a page. They've not taught us this one, no. You didn't teach us this one, no. We're going to be discussed again. You'll not be looking, what is this person writing? 2 pages. And you know it's always you are afraid to write. So, thus, while fungi are dominant in many acid forest soils. Thus, while fungi are dominant in many acid forest soils, bacteria tend to predominate in waterlogged soils. Bacteria tend to predominate in waterlogged soil. Soil that has many water, much water, bacteria will predominate. Deactinomycetes are usually not many numerically. Deactinomycetes are usually not many numerically, but may comprise up to 90% on some soils. But may comprise up to 90% of some soils. Please don't stay on the passage. Let's stay on the passage. Let's stay on the passage. Come and stay this place. I said that deactinomycetes are really not many. But some soils will be part of it. You can go to 90%. Some soils, deactinomycetes can go to 90%. In some soils, deactinomycetes should stop.
This addition not made silt. No, I said this addition not made but it's some my settings. Deactinomycetes are not many in the soil. That's not the way. But when they are in the soil, even few, that's why I say in some soil they go up to 90%. Why? They produce toxin, and the toxin have eliminated the bacteria that are there. So when the bacteria are eliminated, the deactinomycetes multiply and predominate. Abi? Yes. So if I say discuss, so you write on that like 10 points. Yesterday we talked about that clearly. So let's go on. The atom structures are usually not many numerically, but may comprise up to 90% of some soils. Generally, the number of a particular group of the microbes found in the soil. Generally, the number of a particular group of microbes in the soil will depend on the method used to detect them. Generally, the number of a particular group of the microbes found in the soil will depend on the method used to detect them. So you can see just now, I detected those who are not writing. They are at the back. So if I stay here now and ask question, ask you, read it, I will not know they are not writing at the back. But if I went to the back now, I see that they are not writing. As me, I didn't say, well, read the last sentence. I will not know. So from read the right sentence, I'm not just at the back, I'm not writing, I'm just there. I'm looking. So the method you use to detect, if you are using a method that is for bacteria, to check for microbes in the soil, you will not get fungi. If you use a method for protozoa, you will not get bacteria. That's what he's saying generally. The spread of microorganisms, continuation, full stop. The spread of microorganisms may be influenced by their growth patterns. The spread of microorganisms may be influenced by their growth patterns. The spread of microorganisms may be influenced by their growth patterns. Examples are as follows. Examples of such growth patterns are as follows. I told the general level student that any question they want to ask now, they can ask. Most of you are not taking advantage of your time as students. If you finish after 400 level and you have questions you want to ask, you will pay. It's consultancy. It's no longer, I'm not a lecturer again. So after graduation, you call me and say, sir, please, I want you to help me to do this. You will pay. That's consultancy. But now, it's free. It's good you take a good advantage of this. You're not writing, you're not getting from the lecturers the knowledge that they have. You're not come to class. You're not grasping from the lecturers. This note is very old note, more than 20 years now. More than 20 years. But I I got what I wanted. Everything, I take them down. We have other materials which I used in the previous classes. I still go back to this one. Number one, non-migratory unicellular pattern. Non-migratory unicellular pattern. Non-migratory unicellular pattern, typified by unicellular yeasts and non-motile bacteria. Typified by unicellular yeast and non-motile bacteria. E.g., Atrobacter. Unicellular yeast and non-motile bacteria. E.g., Atrobacter. This organism exists in the soil as single-celled. This organism exists in the soil as single-celled or in form of compact colonies fixed to soil particles. Or in form of compact colonies fixed to soil particles.
B. Migratory unicellular pattern. Migratory unicellular pattern. Typified by some bacteria, some fungi, diatoms, and some blue-green algae. Migratory unicellular pattern. Number 3, plasmodial pattern. Plasmodial pattern. Typified by some myxomycetes. Typified by some myxomycetes. Typified by some myxomycetes. Of the myxobacteria, where movement is amoeboid in fashion. Some myxomycetes of the myxobacteria where movement is amoeboid in fashion. D. Mycelia strand or rhizomorph pattern. Mycelia strand. Mycelia strand or rhizomorph pattern. Typified by the hyphae of many basidiomycetes. Typified by the hyphae of many basidiomycetes. Basidiomycetes. This hyphae could become entangled. This hyphae could become entangled to form a mycelia strand. This hyphae could become entangled to form a mycelia strand that grows tough in the soil over long distance. Let's look at diffuse spreading hyphae. Diffuse, the next number, diffuse, D-I-F-F-U-S-E. Diffuse spreading hyphae pattern. Diffuse spreading hyphae pattern. Typified by many fungi in this case, the fungi grow randomly in the soil. In this case, the fungi grow randomly in the soil. The next one is microbial fragments. Microbial fragments. Attendance, how many people did you say are in the class? 151. But this class is like 300 people, are we? So like half will come. Then go will go home. How many are there? Like 10. Microbial fragments typified by many microbes, which can break into small mycelial pieces and spores. Which can break into many microbial pieces and spores. They remain viable in the soil and are moved through the soil by external influences. They remain viable in the soil and can move and are moved through the soil by external influences. What class do you have after this one? Where? Time. In the soil and are moved through the soil by external influences other than active movement of growth, e.g. apart from soil fungi which produce their spores aerially, apart from soil fungi who produce their spore aerially, soil organisms may be dispersed when dry. Soil organisms may be dispersed when dry. Soil is occasionally blown by air current or disturbed in some other ways. When dry, soil is occasionally blown by air current or disturbed in some other ways. Water percolation may also aid the downward movement of microbial propagules. Propagules, G-U-L-E-S. Water percolation may also aid the downward movement of microbial propagules. Some microbial spores are ornamented and colored and covered with hair. Some microbial spores are ornamented and covered with hairs or spine. Hairs or spines. These could attach to the bodies of smaller animals to aid dispersal. This could attach to the bodies of small animals to aid dispersal. One major consideration of soil microbial ecology is the resistance of microbes to extreme environmental conditions. Which include desiccation, high salt concentration, presence of toxins, high temperature, and lack of adequate air. Soil microbes are adapted to these through the modification of reproductive and vegetative structures. Soil microbes are adapted to these through the modification of reproductive and vegetative structures. After your food, what next? When will you finish the food class? We have to schedule another class, even if it's 1 hour, so that we complete. Not what? What are you saying? We have to schedule another class, even with 1 hour. Do we still have this class this week again? So next week. I don't want to come next week. I want somebody else to come next week. So I said through the modification of reproductive and vegetative structures. So what I want to talk about before we end is just reproductive vegetative structures and the it's just 2 pages. So I was talking about the heat and the high temperature in India. That's for 4 months. Another 4 months after that is rain. It's not rain, they call it monsoon. It's not monsoon, it's not monsura. Monsoon. No, we say we have rain here. The rain we have here is not rain, no. Monsoon. Rain will be dripping like this for 2 weeks, non-stop. It will be falling like this. 2 weeks. I will wake up in the midnight, I will look through the window again. Rain is still falling. So, then after 4 months again, the next 4 months is like if you are in the USA or all those inside snow. But this one, there's no snow. But the cold, where I used to sit down, we're looking at maybe there's AC somewhere. Maybe they put AC somewhere that is blowing. I didn't know it's
So after that one, the first 3 months like that, after that one, then heat come. During that heat, there was a day, that day of 43 degrees C. For the first time, I checked temperature. Here, you don't check temperature. You just come out, wake up in the morning, just get out. That place, for the first time, I checked the temperature. So wait till it happen for years. Everywhere hot. Everywhere. Put on fan. Go and take your bath if you are still feeling hot. Then during the rain, you have to spread your cloth inside. You put it outside. Even as you are inside, rain will beat it outside. You will not hear, you know that this rain will be falling here. You hear boo 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 boo, it's nothing like that. Rain will just be dripping, just be falling, and it will continue like that from morning till night for 2 weeks. And then it will stop for like 2 days. It will pick up again. That's why it will go for 4 months. So let's arrange maybe 30 minutes or 1 hour so that we'll complete it. So when you are ready, let me know. So before I go, let me wait. Wait, please. Hold on, please. Please, hold on. Where are you going? Before you start coming to get me for assignment, I will return it now to the class rep. So submit to him. Submit to him. Get them. Same. Thank you.